to welcome our second keynote speaker, Dr. Miriam Sartor. Dr. Miriam is from Sartor, Germany, Gumba, Filtration. She has been an engineer in environmental process technology for more than 15 years of experience in filtration. She actually was the head of department of service technology also, and she was a scientific assistant in the Institute of Environmentally Compatible Process Technology. I believe we have a huge resume down here. We welcome you, Dr. Miriam, and we have 20 minutes for your speech. And thank you.
Thank you for the introduction, and thank you so much for this invitation. And well, we have some minutes until the presentation is on the computer, and so I will just start with my presentation without any slides, because I have a three-step message for you. We are talking here the whole morning already about membranes. And membranes are the first step for a membrane process. The second step, especially for the ceramic membranes, is a module. And the last step is to develop the process for whatever you want to treat. Either a water treatment process or a biotechnological process, or I heard from you from Pakistan, you're working with gas purification, so you need to develop the process. Another point I want to show you today is with that what you introduced this morning. It was so wonderful for me, because it is a step what you did 4 years or 5 years ago, and be patient with what you are doing, because you will see from a first screen today it's a company. And stay curious, because all the membranes, they are so interesting and you can do so many things with it. So now we are talking about Sartor, and you see this blue slide, and it is, well, part of our product. And now I have to go behind this, okay? Okay, I will not go into scientific details. I will show you the technological history of our company. This company is only 2.5 years old, and it has a long history. And I will show you how our process is working, and some installations we did in that time already. Okay, our story started 25 years ago with Professor Schmid from Germany, and he was, well, so curious as you are. And he invented an idea of a ceramic flat sheet membrane. I brought a piece of it, and I think it's easier when we meet during the next days that I show it to you, and I will not give it through, because then you are so busy while I'm talking. And this is a special type of membrane, and it was patented. And one of my colleagues was already with him, and he's now the CEO of our company. It's over here, it's Dr. Martin. And well, in that time, especially the material scientists were working on the membrane development, how to bring this idea of him into a ceramic multi-channel flat sheet membrane. And then they had a membrane, and one research institute in Germany was working with it, and even one company was producing it. But then they needed a module. And it was more than 10 years later that the worldwide first fused pigment plant with this type of membrane was installed. And these ceramic flat sheet membranes are, especially in China now, the hit. Yeah, a lot of companies are producing these type of membranes in China for NBR technology, but this happened after the patent was closed. This was my first contact with this type of membrane, and as you see my picture over here, and I was taking this picture, that is why I'm not on it. And we installed the worldwide first drinking water treatment plant with this type of membranes in 2006, 2007, and this was a test made in Taiwan. And then for many years nothing happened. This was caused by the patent, because only one company had a license and nobody was using it. And after the patent dropped, mega projects started. There was competition on the market. A company in Japan started to produce it, the Chinese one started to produce it, other European companies started to produce it. And then my colleagues had the first mega projects, and this technology got governmental standard in Saudi Arabia for drinking water projects. And this was the time when Sartor was founded. My colleagues and me, or it was more my colleagues, they asked me to join again. They said, okay, now we have the basis to form a company, and we will not produce membranes, because we have now about 15 to 20 companies on the market who are doing this, but the problem is the module. You have good results in the lab to have high fluxes, but the water is not moving through it, because you somehow need to produce something to bring this flat sheet into a pipe, to bring it into a tank, and so on. And this is why they focused on the development of a module, and what we did during all the 25 years was developing water treatment processes. And this is the knowledge we also want to spread. And so the product of the Sartor is a module, an open platform module, and the knowledge to train people all over the world to work with this type of membrane. And so after, well, I think it was 1 year after the foundation of the company, the world's biggest module production was started. And it is not a steel frame like many of these type of membranes are worked with. This is glass fiber reinforced plastic produced by injection molding, and this is why we can produce a lot of modules and be an open platform for any membrane producer. And so I talked a lot about this wonderful ceramic flat sheet membrane, and I want to show you how it works. And first of all, to summarize, we provide this module and we provide the engineering know-how. And this is a typical module. It has, I could not bring it because it's too big, but it has a size like old personal computers, yes? It's about 35 kilograms, so that it can be mounted by 2 persons. And you can, yes, this was one of the construction demands. And you can compile it to a tower and set it into a basin. And this module was hydraulically optimized so that we can filter up to 9,000 liters per hour and module. Yes, this box can make 9 cubic meters in optimal conditions. We just go, some slides for you scientists, into one of the membranes. This is an example of the silicon carbide membrane, and you see here it's an asymmetric ceramic membrane. You have a microfiltration structure with big pores to transport the water, and a thin layer which is the ultrafiltration layer. And this runs extremely quickly with the water and provides these high fluxes. And another part, what we really like, is to use negatively charged membranes with negative zeta potential, because for all the drinking water applications we can clean this membrane easily. So we are going into this membrane. It is a double-sided flat sheet membrane. So you have the active layer on the outside, and you see here the channels. These are the pure water channels. And the particles stay on the outside, and the clean water moves into the inside. And this was the idea which was patented. Not to have it like in a tubular membrane, that you have the dirt and the particles inside and press the water outside. Here you have the dirt outside, can clean it easily, and we are working with suction pressure, like you know it perhaps from the seaweed polymeric membranes, so that we can use really low energy. And what you are doing with this type of membranes, you put it just into a tank. Sometimes you have already one, sometimes you have to construct a new one, and then you suck the water out, and well, that's all. And due to this filter cake on the outside and that you are sucking, you have no compressed filter cake layer, so you give a backwash and then the dirt comes easily off. And here the idea of the Sartor module, we designed it as an open platform so that any of those flat sheet membrane suppliers can use it, and we have a high material stability. We saw that a lot of the steel frames corrode in seawater or in heavy groundwater or in industrial water. And this is why we went to the glass fiber reinforced plastic. And this plastic is very wonderful because it's stable up to 120 degrees Celsius, so you can really use it in any type of water, and you can autoclave it. And we have a very small footprint with this type of membrane, so that you can reduce the space you need for the treatment plants. And I said we are working on the module, and this is the row for the module, and here below we are working even on the process. And we want to reduce the energy demand in any process, and in main processes we come down to 20 watt-hours per cubic meter water treated, and this is really good for such a process. And we want to use as less chemicals as possible, and this is why we always develop the cleaning process, and to reduce the backwash times, even to save water as much as possible. Okay, for the process development, well, we are working with ultrafiltration membranes, and we want to remove particles. We remove all type of particles you have human-made, you have in the water, and we produce particles by adding some chemicals, because these chemicals can capture pollutants in the water, and this is how, for instance, it is possible to remove with this ultrafiltration membrane radium from groundwater. And well, this is a quite good process, and we are working with this process in Saudi Arabia very often. What is also important for us is to develop a good cleaning process. And here you have a picture. It's looking like modern art a little bit, yeah? But this yellow-brown thing is the membrane, and it's just sitting in our lab plant, and this yellow-brown thing is a filter cake, which was produced to remove iron and manganese from the groundwater, and what we want to see is an easy cleaning of the membrane while backwashing. And I hope this, okay, it's not running. I will show it to you if you want to see it on my computer, because it's really slipping down like on a water slide. Yeah? Okay. And so we come to the installations worldwide. As said, we are a company 2.5 years old, and the module was launched 1.5 years or not completely 2 years ago. And we have already a lot of installations. This is cost to our partners, which produce the membranes. Even we sell a lot of plants, and we are working together with local partners. So what we are doing is we provide the module and the German know-how, and we partner in different countries with sales partners and with construction companies, and train them and supervise them and make designs for the plants. And so this is possible to bring our knowledge all over the world and to work together with several companies. And this is why we have a lot of installations. And I brought just some examples to show you the differences which is possible to do. This is one of our research projects or demonstration projects, and this was done in Saudi Arabia. And the main focus with this project was to demonstrate a really high flux. This module was designed for a hydraulic high flux, and we wanted to see it. And in this demonstration, we demonstrated a flux of 1000 LMH. This was possible because the water in this groundwater aquifer is about 40 degrees Celsius warm. And so you really can improve your flux very much. But even if you calculate it to 20 degrees, which is the standard, it's more than 600. And, well, it's not so good to see, but this is the pressure. And with the suction filtration, you have a pressure drop, not an increase. Yes, it's different compared to the pressurized membrane systems. And what you can see is that the pressure increase, and each of these going down and up is 12 hours. And after backwashing, the pressure was the same again and again and again. And so you see that we have almost no fouling in this process. This process is running quite well at this high speed of the membrane. And in another application, they even demonstrated 1500 LMH. But this is the maximum limit we can do with our module, but it's 10 to 100 times higher than any other module. We installed a full-scale plant in Jordan for a city with 250,000 people living there, and this was done in July of the last year, and it is running there since almost 12 years. And this was an exchange of a sand filter. And by taking out the sand of the sand filter and setting in this type of membranes, because you can just put the tower into the basins, you can increase the capacity of such a filter by 3 times, or you just need 1/3 of the space. It depends on you what you want to have. Another full-scale plant was installed in Iran. This was another type of water. That one in Jordan contained even some radium. And here it was the main target to remove organics, because it is a groundwater, very surface near, and they have a lot of pollutants there from organics. And even here, the water runs, the membrane run well, and they are a pre-treatment for a reverse osmosis, because it is close to the Caspian Sea and there's some brackish water in the ground. And by using ceramic membranes or even some polymeric ones in front of an RO instead of sand filter, you can improve the operation of the reverse osmosis very much. This is a totally different thing. This is in Thailand, and this is a pool cleaning truck. And this pool cleaning truck was installed by the Thai partner, because in Thailand you are not allowed anymore to use chlorine to clean your pool. Yeah, it's a small truck. And you can now use ozone or you can use this type of membrane. Yes, they have the trucks, they come to your pool, then the truck runs for 3-4 hours, and then the pool is cleaned, and then it goes. And next week it comes again and cleans the pool again. Yes? So this type of module we invented is very small, very modular, and you can even install very small systems, mobile systems, and so on. Yeah? Another totally different application is fish farming. The fish farming this time is in Scandinavia, and you see that the flux is now about 200 to 250 LMA. This is due to the cold water, and that you have a lot of organic in the water because the fish is fed with organic and the fish makes poo, and here you have to reduce the speed, and this is why we have a lower flux. And this is again process development and to find the correct backwash and so on. And we are here running side by side with tubular membranes, and this is very nice for us to compare. And due to our cleaning process, we are only cleaning with chemicals outside of the membrane. We have no contact with chemicals with the permeable. And this is what the customer likes because his fish is very valuable and he do not want to have chemicals in contact. Again, totally different application is membrane bioreactor technology again, and this is the old plant which was the first installation worldwide with this type of membrane, and we set our module inside last year, and it ran for 5 months without cleaning, and after 5 months we said, okay, now we do a chemical cleaning, and this is a test field for us, and we like it very much. Well, these are some of the applications. One we really love by heart is containerized solutions, and to bring mobile solutions to everybody in the world. And thank you very much.
Thank you, just in time. Very interesting. Thank you, Miriam. It was very interesting, especially the mobile cleaning system will be very useful for swimming pools. Just to stop using all this chlorine in the swimming pools. I believe the product is very successful in removing organics and heavy metals, but it doesn't work that much with salinity, I think. So it's another stage here. Before salinity.
Yes. It is ultrafiltration, so it can remove particles. You can make a process even with combination of flocculation and particle removal, but it will not remove salts. So there you need reverse osmosis, but reverse osmosis process is often very expensive, and you need high pressure when you have still some particles you bring on the membrane and so on. And when you use this as a pre-filter, the reverse osmosis improves.
And you save money for reverse osmosis. Thank you very much. Anybody has any further inquiries for Miriam? Okay, thank you again, Miriam.